Hello, everyone, and welcome to the TDWI webinar program. I'm Andrew Miller, and I'll be your moderator. For today's program, we're going to talk about automated data and analytics workload modernization, and our sponsor today is Impetus. For our presentations today, we'll hear first from James Kabilas with TDWI, and after Jim speaks, we'll be joined by Veena Vasudevan with AWS and Samiksha Saraf with Impetus. Before I turn over the time to our speakers, I'd like to go over a few basics. Today's webinar will be about an hour long, and at the end of their presentations, our speakers will host a question and answer period. If at any time during these presentations you'd like to submit a question, just use the Ask a Question area on your screen to type in your question. If you have any technical difficulties during the webinar, click on the Help area located below the slide window, and you'll receive technical assistance. And if you'd like to discuss this webinar on Twitter with fellow attendees, just include the hashtag TDWI in your tweets. Finally, if you'd like a copy of today's presentation, use the Click Here for a PDF line there on the left middle of your console. And in addition, we are recording today's event, and we'll be emailing you a link to an archived version so you can view the presentation again later if you choose, or if you'd like to share it with a colleague. Again, today we're going to be discussing automated data and analytics workload modernization. And our first speaker is James Kabilas, the Senior Director of Research for Data Management at TDWI. Jim is a veteran thought leader, industry analyst, consultant, author, and speaker on analytics and data management. And over the past 3 decades, Jim has held analyst positions at Viterm Research, Wikibon, Forrester Research, Current Analysis, and the Burton Group. He also served as Senior Program Director, Product Marketing for Big Data Analytics for IBM, where he was both a subject matter expert and strategist on thought leadership and content marketing programs targeted at the data science community. At TDWI, Jim focuses on data management, which encompasses database platforms, data governance, data integration, master data management, data ops pipelines, and more. Please welcome Jim, and with that, I'll hand it over to you.
Thank you, Andrew. Hello, everybody. I hope you're having a good day here. Let me just advance to my first slide. And having a bit of trouble on my end visualizing it. Just a moment, please. If you find the right one, I'll be right with you. Here we go. Yes. Okay, yes. Well, it's a pleasure to be speaking with you today on the topic of automating the modernization of data and analytics workloads. I cover data management, and data modernization is a core theme in the enterprises everywhere. And it means a lot of different things to lots of different people, but really what data modernization fundamentally is. It's the process of evolving your data platforms and the tools and infrastructure needed to support the processing and cleansing and consumption and delivery of that data for a wide range of use cases, from transactions through analytics and the like. So when we talk about data modernization at TWI, we're referring to the process of evolving those platforms, tools, and infrastructure to support new patterns under which data is structured, consumed, distributed, contextualized, governed, originated, and processed in the business world and really every sphere of life. So data modernization delivers, well, ideally, you should be modernizing, migrating your current environment to a modern data environment to achieve particular improvements in production-grade scalability, performance, flexibility, cost-effectiveness, and manageability of all your data and data analytics applications and other applications that rely on data. In coming years, at TWI, we see enterprises increasingly migrating their data and analytics assets to run in modern environments. Migrations are a big part of the overall modernization picture. Migrations of an existing enterprise data environment can be fearsomely complex depending on what workloads and what data sets and so forth need to be migrated and to what environment and how quickly, under what circumstances. Migrations, you want to do it in a way that's not disruptive to the business, but enables you to accelerate time to value of the deployment of a modern data platform into your organization. So when we look at modernization and migrations as key to that, what is pivotally important in migrations is to automate the movement, conversion, and operationalization of data sets and analytics workloads and other aspects or artifacts or assets that constitute your entire data and metadata environment. And to automate the movement of it all to cloud-native or cloud-centric architectures. So advance to the next one here. So when we look at some recent TWI research that's relevant to data modernization and migration of workloads, what we asked in the data and analytics survey this year to data practitioners, data and analytics practitioners, is what is your primary motivation for evolving and modernizing your organization's data strategy? And on-demand analytics, in terms of a broad set of use cases, is the primary use case for modernizing data platforms. That was clear across the board, and that's been a consistent response from the community, the TWI community of practitioners over the years. Modern analytics to support increasing data volumes, to support a growing range of data types, to reduce costs and improve efficiencies on managing and delivering data downstream. Enterprises are migrating their data analytics workloads to a wide range of modern architectures to achieve greater functional breadth in terms of the use cases that are being addressed, scalability, efficiency, to enable self-service data and analytics across the board, both for users and data governance, data stewardship professionals and others. And also to achieve greater automation in the operationalization of data and analytics in the targeted environment. So when we look at, go to here, when we look at one of the key target environments for a lot of modern data migrations, serverless platforms are becoming serverless environments. Cloud services are becoming critically important in many enterprises' data strategies. Serverless is one of several approaches in terms of modernization of data architectures, but it's increasingly coming to the forefront, and some of our speakers today will discuss new serverless cloud offerings that can enable a wide range of use cases. Serverless as a whole, as a paradigm, refers to data and analytics workloads that are consumable as event-driven stateless functions. And what we see is a lot of data and analytics workloads fit that bill in terms of can be defined as functions that are event-driven and stateless and can scale up fairly rapidly and scale down as needed. Serverless is becoming the core modern cloud approach for scaling many types of data workloads. So when we look at serverless as an approach for migrating and modernizing your data estate, there are several key advantages that TWI has identified in our research for serverless. It's scalable. Serverless is based on-demand, dynamically provisioned, and scalable delivery of data management and analytics services in the cloud. It's efficient. It lets users pay for only those processing cycles and other resources that are consumed for the time that the enterprise's particular serverless code is running, rather than paying for idle capacity. So it's efficient. Serverless as a general paradigm is agnostic to the underlying data and analytics frameworks that are being presented as consumable microservices through serverless. Spark, Hive, Presto, HBase, MapReduce, you name it. Most data analytics, especially open source platforms, have increasingly a wide range of commercial serverless offerings available for enterprises that want to consume these analytics frameworks in this fashion. Serverless is consumable for the end user, for the developer, really. It presents a consistent, secure, language-agnostic, and web-native API that can be called from any client application. In fact, has been bound to pretty much the full range of enterprise programming languages you might use, Python, Java, etc. Serverless is composable. It enables enterprises to deliver composable data and analytics functions as microservices in a way that's abstracted from the underlying physical locations and operating platforms in the cloud from which the back-end application logic is being served. And eliminates serverless, the need for programmers to write logic that manages things like containers and virtual machine and other back-end runtime engines. And last but not least, serverless, one of the key advantages is how operationalizable it is. What that means is increasingly organizations are outsourcing their data platforms and infrastructures to cloud providers who deliver serverless capabilities on a fully managed basis that's capable of elastic scaling, and which is continually optimized and highly available within the cloud provider's environment. And this helps enterprises, the enterprise customer that's using serverless data, to avoid the operational pain points that would otherwise accompany them trying to run these big data applications in-house on legacy on-premises processing platforms. So when we look at some key takeaways that TWI has for enterprises that are going the serverless route in terms of modernizing their data and analytics environments, what we recommend is that you rethink your data and analytics applications with serverless in mind. Event-driven, stateless functions are a key element of the data pipeline, many processes there, but also a fair number of front-end analytics applications can be written with serverless code in a way that that's highly efficient and scalable. Serverless is not for every single application. Serverless doesn't deal with stateful interactions or capabilities within your application environment. There are various approaches for supporting application state within serverless environments, but that's outside the scope of today's discussion. We recommend that you integrate your data analytics and development environments with serverless, meaning make sure that your development environment supports libraries that allow you to make calls to serverless offerings of your preferred cloud provider through your preferred set of programming languages. Avoid building a siloed serverless big data infrastructure if you can to achieve the scalability and efficiencies of serverless. Select a primary strategic suitable serverless cloud data provider and platform for your needs. And there's many on the market, and once again, evaluating and comparing them is out of scope for today's discussion. Convert your legacy enterprise data and analytics assets and code and so forth to serverless functions that present open cloud native APIs. That's quite important. So there'll be a fair amount of conversion that you'll need to do to transition your legacy data analytics to serverless environments. Provide your enterprise data personnel and analytics personnel with tools that are geared for developing, deploying, and managing serverless code in production. And automate every step of the migration of data and analytics to the target serverless data cloud. Critically important because these can be fairly complex undertakings, these modernizations. And today we have in a panel of two industry experts who will join me to discuss a variety of questions related to modernization and migration of data and analytics into the cloud, taking advantage of serverless. So I'm going to hand it back to Andrew to introduce the panel.
Terrific. Thank you very much, Jim, for that great presentation. Before I introduce our panelists, just a quick reminder to our audience that if you do have a question, you can enter it at any time in the Ask a Question window. We will be answering audience questions in the final portion of our program. This does bring me to our next speaker, who is Veena Vasudevan, the Senior Big Data Solutions Architect with AWS. She has been working in AWS for the past 6 years as a subject matter expert on Amazon EMR. She helps AWS partners and customers migrate their Hadoop big data and analytical workloads from on-premise to other cloud providers to AWS. As global Amazon EMR acceleration lead, she creates and delivers enablements focused on big data modernization and best practices to AWS partners worldwide. We're also joined by Samiksha Saraf, Principal Cloud Architect with Impetus. Samiksha works closely with customers in driving technology plans to enable strategic business initiatives. With 17 plus years of experience, she brings deep expertise in architecting and implementing large-scale enterprise systems to address complex business problems. Please welcome Veena and Samiksha. And with that, Jim, I'll hand it back over to you for the panel discussion.
Very good, very good. Okay, so we're going to move to the first panel question. And after the panel, there will be a demo, I should point out. And then we'll have audience Q&A. But my first question is for Samiksha. Samiksha, what does it mean to modernize how an enterprise puts its data and analytics workloads into production? Modernization, what does it mean? You've heard my definition. We want to hear yours.
Sure. Thank you for inviting me, first of all. And I would like to begin with a little context setting here. So many organizations are dependent on a large number of legacy platforms and applications at the core of their business operations. And the legacy platforms that I'm talking about here are, the ones that have existed for 10 to 15 to 20 years. And enterprises have invested a lot of efforts in building these platforms, and these are some of the mission critical applications for those organizations. Now, over the years, the data and the usage of these platforms has increased by multiple folds. And now, due to limitation of the underlying technology itself, not only in terms of the features, but also supporting more business functions in the infrastructure it is built upon, enterprises are looking to move out of these legacy platforms. And when they want to move out of the legacy platforms, they're actually not looking for any business disruption. So here, to modernize the legacy platforms means to bring in more efficiencies to deal with a larger volume velocity of data, to adapt to ever-changing business scenarios, to be able to support newer use cases from analytics to business reporting, as you said, to going more real-time, accommodating more data without overrunning the cost, to reduce the overall time to market, and to consequently also reduce the time to value. Now, essentially, it is talking about modernization is taking your legacy platform to a state which is futuristic and can reshape itself to this ever-changing world of technology, and doing this all within the periphery of a much cost-effective solution. Now, modernization is often interchangeably used with migration, but modernization is much more than migration. It is not just about data migration and a change of technology. Modernization is a complete data estate rehaul wherein all your data, the jobs that are executing on top of that data, the applications, the downstream systems, also the security, compliance, and the way governance of these applications and tools is done is taken to a completely different level. And today it would be rightly said that to modernize would be to move to cloud. I would rest my answer here unless, Veena, there's something you want to add.
Yeah, I think that pretty much summarizes the answer. I'll talk about the challenges and more about modernization in the next question.
Sure, we'll move on to challenges. So Veena, you've begun the discussion. What are the principal challenges that enterprises face when they're moving their on-premises data platforms to a modern cloud architecture? Challenges.
Sure, and thanks for the introduction and for inviting me as well. So that's an important question. And as Samiksha pointed from her points, you can realize that modernization is actually the need of the hour for several of our enterprises and organizations. But there are several modernization challenges that actually slows down our customers significantly. So let me talk about some of the most important challenges. And from my experience of working with several of our customers, their first concern is the costs and the budget overruns due to migrations. And for some statistics, for instance, McKinsey reported that over the next 3 years, there will be up to like $100 million wasted on migration spend. And most enterprises attribute the costs around migration as the major inhibitor to the cloud adoption. And secondly, it is the complexity. And Hadoop ecosystem itself has a number of areas of complexity around things like data ingestion, storage, processing, security management, and so on. And during a migration, you need to consider all of these areas. And Hadoop ecosystem, for those who have worked on it, you might also know that it is also very diverse, where customers can run a multiple of applications in on-premise, like Spark, Hive, Presto, HBase, and so on. And they also have a lot of dependencies with each other. Also, there is a lack of documentation for transforming the business logic within the legacy code. And without the proper documentation or automation tool to extract this particular logic, it is challenging to migrate and modernize, especially when we're talking about like thousands, tens and thousands of lines of application code. And even today, a lot of migrations that we see from our customers are surprisingly done manually, even at the enterprises level. And as you know, manual processing is very prone to errors and it's time consuming as well. And enterprises often lack the tools for automation as well as the time-tested methodologies that are necessary to make some of these projects successful. And we see that a lot of projects fail due to the lack of these set methodologies and tools and frameworks. Or they actually take well over 2 to 3 years for the entire migration and modernization journey, which obviously increases the cost. Or like Samiksha pointed, it will lead to business disruptions as well. And most of these enterprises, they also have skill gaps when it comes to data migrations and transformation. So when there is a migration task, it obviously requires a very steep learning curve for the developers to execute some of the mission critical tasks. And a lot of the organizations have also been using Hadoop for over a decade, which introduces a number of technical challenges and risks, like understanding dependencies across the environment or identifying the technical depth and complexities in the ecosystem. So to summarize, enterprises... Sorry, go ahead.
I was going to ask, is migrating a Hadoop deployment to the cloud, does it present any special challenges above and beyond migrating any other legacy data platform to the cloud? Is there something especially complex or challenging about a Hadoop deployment or Hadoop migration to the cloud?
Absolutely. So like I said, Hadoop ecosystem is a lot more complex compared to a regular workload like data warehouse migration. I would say, it's a little bit more straightforward compared to Hadoop ecosystem. With Hadoop ecosystem, we are talking a lot of application, diverse applications, like I said, Spark, Hive, Presto, and more. And need a capability that sort of understands the infrastructure and capacity and also these different applications and workloads and transform them seamlessly. So that is definitely a challenge.
Do the complexities of Hadoop clusters grow over time? After they've been deployed for years, does it become more difficult or costly to migrate them the longer they've been in deployment?
Absolutely. So as you can see, if you've been in Hadoop for a long time, and if you're on an older version of Hadoop, then those who have done the migration from even Hadoop 1 to Hadoop 2 several years ago, they might realize the vast number of changes that are required in their application, for instance, right? So there is a lot of changes required, especially the older your deployment is, the harder it is.
Okay, that's great. So Veena, and Samiksha, let's move on to the next question. What automation techniques, tools and techniques can best address these migration challenges to maybe make them less costly or less complex or less glitch prone? Automation. Is automation the answer to migration and modernization?
So there are a number of ways to modernize and productionize pretty much your on-premise Hadoop workloads. And like I said, most of our enterprise customers, they do it manually, which is often time-consuming, error-prone, and risky. Now, talking about some of the nuanced technologies for modernizing Hadoop workloads, Leap Logic is a key product that can help with accelerating and modernizing migrations to AWS from your on-premise Hadoop clusters. And AWS has had an ongoing and long-term partnership with Impetus, and they have helped several of our AWS partners and customers migrate and modernize their workloads to AWS. And Impetus has built Leap Logic Accelerator, which helps our enterprises and customers embark on their modernization journey. Right from the beginning, from the ideation phase to the go live phase, right? And Leap Logic Accelerator also helps with the end-to-end life cycle of the modernization journey. And it has built-in capability to do both data and metadata migrations, which is pretty unique. And when it comes to security as well, which is very important, I would say it's the most important thing. And Leap Logic understands your security infrastructure and policies and compliance measures, and it incorporates them into the final product that they're trying to build. So when it comes to workloads as well, there can be thousands of different types of workloads and across multiple systems. And Leap Logic has a grammar-based engine to sort of understand your workloads and modernize them. And also it sort of the accessories like orchestration jobs and ingestion jobs are also supported by the acceleration tool. So I would like to give a quick customer reference if that is okay.
Yes, please.
Yeah, so United Airlines is a great customer reference. For instance, they wanted to migrate their over 20-year-old legacy data pipeline into AWS for personalizing the user experience. And this was during the COVID-19 crisis, where airlines had to check the travel readiness of passengers, and they needed to do it in real time. And they wanted more of a modern data platform to meet their growing business and technical requirements due to the times that we are in. And LeapLogic helped United Airlines modernize over 200 batch programs and over 30 real-time workloads using different AWS services like Lambda, Managed Airflow, Glue, EMR, and so on. And they also provided automated data quality and integrity checks and single-click deployments and so on. And these automation capabilities of LeapLogic helped United Airlines save about 22% of the time and 70% of the efforts compared to doing it manually. And as a result of this modernization project, they were able to auto-approve travel readiness of passengers, using vaccination reports for COVID, for instance. And they were also able to reduce the wait time at the airport by predicting if the passengers have met the COVID screening requirements. And they were also able to personalize and target promotion offers for their customers as well. So LeapLogic basically does this modernization journey in 4 different phases: access, transform, validate, additionalize. I'm not going to talk about them in detail because Samikshar will step in to talk more about it, and how LeapLogic Accelerator works in a demo as well in the later part of the session.
Great. Samiksha, do you have anything to add to what Veena said about automation?
Yes, definitely. So I think Veena has covered it quite well, but I just want to focus on the most prominent aspect of LeapLogic, which is bringing in the power of automation when dealing with complex modernization journeys to the cloud. And it is this automation which brings in a lot of speed to the modernization journeys. Along with speed, over the years, this product is battle tested. So there's a lot of reliability that comes underneath. There's a lot of consistency and uniformity that you will see across the deployments. Every customer is different, every workload is different, and every customer journey, even if we are talking about the same sources and targets, is different. But because this is a pattern-based engine, it is able to identify the patterns and reuse those patterns even if they're occurring somewhere else within the same customer engagement or if in a different customer engagement. So I just wanted to highlight that aspect of LeapLogic. Thank you for asking.
Oh, yeah. Because I think LeapLogic, you do SQL to SQL transformations. Does it do transformations beyond SQL transformation?
Yes.
So complex projects. Yeah.
Yes. So when LeapLogic started, it started with SQL transformations, and then this I'm talking around say 6 or 7 years back down the line. But today, LeapLogic is much, much, much beyond its initial set of capabilities. So it is not just a query translation and a query to SQL transformation engine, but the modernization candidates can be beyond your enterprise data warehouses, which may be built using Teradata, Netezza, SQL Server, Oracle, etc. It also takes care of legacy ETL pipelines, which are built using, say, Informatica or Ab Initio or Data Stage as the source. And you can take them to any targets, be it Glue or something else on AWS. Analytical tools like SAS. Now, SAS is a complicated stuff, but LeapLogic has a new addition in terms of SAS modernization now. BI tooling, so we can also take care of your reporting, which was originally getting done using, say, Cognos and taking it to QuickSight or anything else on the cloud. And now we mostly, for say some years back, we were seeing Hadoop falling onto the target space wherein customers wanted to move out of their enterprise data warehouses hosted, say, on a SQL server and wanted to leverage the benefit of Hadoop. Now, we are also seeing the on-premise Hadoop setups coming to us on the source side, wherein customers now want to come out of their Hadoop on-premises setups, and they either want to leverage something like EMR on cloud, or they want to go and have a more elaborate architecture wherein the data warehousing, which was taken care by Hive in the Hadoop ecosystem, now moves to Redshift. The processing goes to Spark within EMR, and reporting goes to QuickSight. So all is this a unified architecture on the cloud. And LeapLogic very well handles not only the assessment of the source platforms, but also their transformations to the modern native cloud stack also.
Very, very good. Okay, that's great. So let's move on to the next question. In fact, you mentioned EMR. That's Elastic MapReduce, of course. That's an Amazon Web Services offering. Now, I believe there's a serverless EMR now. And so when we think about serverless architectures or serverless as a targeted platform for modernization and migration of data and analytics, and I'll ask Veena first to give your thoughts on this. How can a serverless architecture help enterprises to address the challenges, the ongoing challenges of productionizing new data and analytics workloads? What are the advantages of migrating or modernizing to serverless?
So it is a very important question because we've seen this trend where our biggest enterprises and some of our largest AWS customers are interested in moving towards a fully serverless architecture, right? So I'll talk about the serverless architecture and their advantages first, and I'll touch upon EMR serverless. So if you have worked in an on-premise setting, you should be aware of the tedious infrastructure, procurement, and maintenance challenges. First is you need to procure the hardware, and also after you procure the hardware, you need to maintain it with OS patching. And scalability is also a challenge with having to add and remove servers, and it takes a while to do that. The first advantage of going fully serverless is the fact that it eliminates dependencies on the underlying infrastructure, and it also helps the developers focus on the right things. By what I mean by that is with serverless architectures, developers are able to focus solely on the business functionality, the core business functionality, rather than having to manage the underlying infrastructure, like containers or virtual machines, EC2 instances, or any other backend runtime engine that typically runs your workload. And serverless architecture also provides, I would say, a layer of abstraction over the underlying infrastructure as well. And the serverless architecture, with that, it helps you achieve a higher degree of density, and also it increases the efficiency of your resources, like CPU, memory, storage, and so on, compared to the on-premises. And the serverless architecture also helps you achieve the high degree of scalability, like I said, the challenge that was introduced in on-premise. The resources scale up and down dynamically and automatically in a fine-grained manner, and it's based on the resource utilization, CPU, memory, and storage, which means that the customers actually end up only paying for what their workloads actually use. They are charged for the processing cycle consumed for the time their code is running, which means that they're not paying for any idle servers or virtual machines or containers. And this is the same principle, all the serverless advantages I talked about, the same applies for EMR serverless also, and we built that based on these principles.
Great. So make sure anything to add to what Veena's had to say? Or can I move on? I'll move on. So what modern, I'm sorry, did you have something to say?
I took a moment to unmute, but I think she covered it all. Thanks.
Okay, very good. Okay, so the last of our panel questions before we move to the demo, in addition to what we've discussed, serverless, but really what is the broader stack of modern technologies and tools that are pivotal and essential for putting data and analytics workloads into production? It's serverless, but what else in the modern data stack is essential for these kinds of migrations and for the success of the ultimate target environment in a modern cloud native context? I'm going to ask Samiksha to take the lead on this.
Sure. So you kind of rightly pointed that yes, serverless is the way to go. But other than serverless, as Veena was mentioning, so EMR comes with multiple flavors, and you pick and choose the one which is most suited to your business scenarios. So you would want to, you may want to still go with a long-running persistent EMR cluster, given that you are executing the same workload over and over again, say every 5 minutes or so. If that is the kind of processing you need, then you have one flavor, which is a long-running cluster. Now, another way to look at it is there are monthly workloads, there are workloads that are getting executed on a weekly basis. There are also quarterly runs that happen with a lot of data processing. So those may require a different flavor of EMR in place. Now, I'm giving this answer in the context of EMR, but in terms of modernization, currently, cloud presents a wide range of choices. If you talk about ETL, and there you will get a support of more than one ETL opportunity on the cloud. Even in case of serverless is the way to go, but there are transient options. There is automation in place which can, achieve a predefined set of resource consumption more neatly, wherein you know that this is the kind of instances you may want to, when you can go for, just buy some spot instances and schedule your workloads on them to reduce the cost, because it is a monthly workload and there's no SLA associated with it. So there are many, many options. One of the most pivotal things that I think is the call of the hour is dealing with automation. Now, whenever we talk about cloud in particular, we are talking about automation almost everywhere. We talk of automation when we are provisioning our resources. We talk about automation whenever we are setting up a cluster. We talk about automation in the context of, we are talking of automation when we are dealing with monitoring, alerting, and whatnot. So when we are dealing with modernization, we should be dealing with automation even in modernization, in the context of modernization. So automation should be the strategy whenever we are planning to move to the cloud, whether we are doing a fresh setup on cloud or whether we are going for modernization to the cloud. Automation should be the key strategy, and which will also benefit us a lot in terms of controlling cost overruns, which come as the biggest pain point later if not monitored, well in time.
Okay.
So with that, I would like to move on to the methodology that we use at LeapLogic, and I would like to touch upon the challenges that Veena laid out towards the beginning, and how do we address it when with LeapLogic solution, providing the solution of automation to modernization to cloud.
Okay. I'm going to hand it back to Andrew. We want to move now to the demo portion of our program. So where should I advance the slide to?
Sure. Yeah, I think, Samiksha, you had a demo that you'd like to show everyone. Is that correct?
Yes, I do.
There we go.
So go right ahead, and you can use the screen share, and you can begin.
Sure, thank you. So before the demo, just a quick context setting, and I hope everyone here can, everyone here can see the slides I have put in. Just few slides for a quick context setting. So we've already talked about LeapLogic and how it is helping, how is it helping the enterprises to modernize their legacy platforms. I quickly want to talk about the methodology through which I also want to convey on how we are talking about solving the migration challenges that were outlined by Veena also in the beginning of this discussion. So we follow a 4-step methodology to transform the legacies to the modern platform. And the first step is the assessment, wherein we set the right foundation for a successful migration. Now, assessment and analysis is completely automated through Leap Logic. We do a discovery of the source platform, create a complete inventory of the jobs and the applications and the workloads that are getting executed on that platform, along with the complexity of the business logic involved. We do a dependency analysis and identify the technical debts. And using all this information, we have subject matter expertise available within the services wing of Leap Logic, who can set up the right migration strategy, work on workload prioritization, the target architecture and capacity planning, and make help the customer in making more informed decision about the modernization and migration. Now, setting up the right foundation through automation is the beginning that we want to give to our customers. The next major area where Leap Logic tremendously helps is the migration and transformation stage, wherein we do an automation of converting your source code in an automated manner to the target. It is not a simple line-by-line conversion. It is not, a simple string replacement. It is much beyond that. It is a pattern identification process which uses a comprehensive grammar engine and then, converts the patterns to their target optimized structures. Then we have validation. Now, validation is one of the most important exercises, and whenever we are going for a manual way of dealing with modernization, this is often underestimated and overlooked. So validation here, Leap Logic, the kind of validation it supports is it does both the data validation as well as the workload validation. When I say the workload validation, essentially whatever output the workload or the job was producing at the source, it is the exactly same output that the businesses expect to be produced on the output side at the target. There are multiple, features to the validation wherein you can do an aggregate-based validation, to a sample validation, to even the most comprehensive validation wherein if you want to check the cell-by-cell value at the source and the target and want to match. And one of the most beautiful things that come out of the validation, the automated validation toolkit is the report, which presents the exact record where at the source and the target with the values that did not match, so that it is easier for anyone who is reviewing them to understand the differences and take appropriate actions. Other than this, Leap Logic also helps with operationalization to the cloud. In the operationalized stage, we integrate legacy tools and existing processes to cloud-native services and deal with orchestration. And this provides the DevOps-ready, modernized environment, which is ready to accelerate, to take up new workloads, and to create a system which is future-looking. Now, this is just a pictorial representation of what we have been talking about in terms of Leap Logic. On the left side of the screen, you will see the different sources. As I said before, it is not just SQL, but it also includes your legacy ETL platforms, legacy orchestration pipeline, legacy data platforms, be it data warehouses or Hadoops or your databases. The different stages that I just talked about that Leap Logic takes care of. And then at the right are the targets, wherein for ETL and orchestration, particularly in the case of EMR, you may want to go with Glue, or particularly in the case of AWS, you may want to go with AWS Glue or Amazon EMR. For EDW, Hadoop, and databases, again, there are multiple choices within the cloud that are available, which can be chosen based on the client requirements or based on the client's execution patterns or based on the kind of workloads the particular client is dealing with. And definitely there is also BI integration that is developed lately and is automated. The BI modernization is automated into the product suite as well. Now I would go through a quick demo and although we support enterprise data warehouses and ETLs and Hadoop modernization, in the demo, I would want to concentrate on the Hadoop modernization, Hadoop modernization section of Leap Logic. This is the application which is used for Hadoop modernization. And as we talked, modernization is not just transformation. It is also doing an intelligent analysis and assessment of the source cluster. So the moment you land into the Leap Logic application, there are different sections present within the application which can deal with an assessment or a discovery of your current platform or the source platform. We can deal with transformation. There is code assessment, which is also newly built in when we talk about Hadoop modernization, and also validation, which is not showcased here in the demo, but is a very integral part of the toolkit. Now, Hadoop modernization typically begins with doing a discovery and an assessment. Now, there are various modes in which the Leap Logic application and the toolkit executes. So first, I want to talk about the comprehensive and the quick mode of assessment, particularly in the context of Hadoop modernization. So when we are doing an assessment of the source Hadoop cluster, we can take a comprehensive route of doing a discovery and assessment of the Hadoop cluster for 3 to 4 weeks. We can also do a very quick assessment wherein we can plug in the Leap Logic assessment agent for, say, something like 2 days, get all the insights from the platform and build a quick report out of that. Even with quick and comprehensive modes, we are offering both an online version of the assessment as well as offline version. So the online version requires us to set up and integrate an agent to a running Hadoop cluster. So the agent, gathers all the relevant information from various APIs, from various tools that are set up, in the Hadoop ecosystem, also reading through the logs and the responses, and then creates the assessment. Then you have the offline way of doing assessment, in which we request certain information to be in the form of logs and responses to be presented to us in the sense to be presented to the application. This is the set of application that is needed. Once this application is made available to the product, it can deal with doing a discovery and assessment in an offline manner without having an active connection to the Hadoop cluster. Now, quickly moving to one of the completed discoveries here. So this is a discovery we ran for 7 days for a relatively small cluster, a local cluster. And this is the first screen that we are presented, wherein it goes from easy to tough. So initially you are presented all the hardware details and cluster details and infrastructure details. Moving next is the utilization of the system, wherein we present both the YARN utilization. Impala, in the case of Cloudera, does not run on YARN, and its utilization is separately called out. We present the active users of the system and also the resource consumption by these users. The queues, currently the unutilized queues is none, so that is why it is not coming up here. The memory utilization summary with high memory utilization and low memory utilization slots are presented in the analysis. A queue discovery is done, wherein we try and understand if on the on-premise Hadoop environment, if there are multiple YARN queues that are set up, then are they getting utilized as per their allocation? And this is the view that kind of describes that. Moving next comes the data and storage, wherein we present to the user the data growth rate and on a daily, weekly, and monthly basis. And this growth rate is calculated, is not a linear calculation. It is more intelligent and is compounded to get to the real to the real numbers. Since we are dealing with many jobs and applications that are getting executed on the Hadoop cluster, the analysis report here presents the total number of applications that are getting executed and how many of them are unique. Unique in the sense, so you will have the same application, you may have the same application running multiple times a day, or maybe taking care of the same application or the same query getting executed at different intervals. So all those instances are come under total number of applications. And if we want to understand only the unique number of queries and application, then that is what is presented in the next, the next block towards the right. While assessing the Hadoop platform, which is Cloudera platform in this case, we also present the user with top workloads. Now, the top workloads can be on the basis of their memory consumption, the CPU consumption, or the ordering as per the duration of these workloads, wherein the workloads that are running, taking more time than others come at the top and the rest at the bottom, and also the frequency of execution. So let me just give you a view of how it looks like. You just delve deeper into it and you are presented next screen, which lists down the workloads, the relevant queries and applications, the users, the queues, the average memory vCore consumption, and also the number of instances, wherein the number of instances is the number of times this workload got executed, and the average duration that workload got executed in. Once we are done with the top workloads, the next section is, so Hadoop is not about just Spark applications or MapReduce applications, but it also has orchestration. Currently, there are no orchestration scripts here, so I cannot showcase that, but I can showcase the ingestion workloads now. Ingestion here, it talks about fetching data from relational databases and also putting data back to these databases, which in the Hadoop world is done using Scoop. So this is the view that we get, which mentions both the cases, whether it is an import or an export. You can see the detailed workload here. Whatever I have been showcasing till now, all this information, we understand that for a system like Hadoop, which may have thousands and thousands of workloads getting executed, on a weekly basis and many hundreds on a daily basis, it will be difficult for anyone to analyze all that information and, move in a paginated fashion through the UI. So there is a report section. And there are many reports available. For example, there is the application summary report, which provides with the application stats of memory, CPU, along with the duration and number of times the workload got executed. We are also presenting an all workload reports, wherein all workloads of the Hadoop cluster are getting reported. Then you have the orchestration, data ingestion, and recurring workloads report. In the interest of time, I would move a little more quickly. So after the reports, one very interesting area I would like to cover is this recurring workload identification. Now, for a legacy platform, it is very interesting to know if there are any recurring patterns wherein you can know whether certain workloads are getting executed after a certain interval of time on a repetition basis. So this is where this is analyzed, wherein the workload is identified and also its frequency, whether it is running every day or every minute or every week, is reported here along with its recurring instances. This is one of the most powerful features because it helps us decide the target capabilities that we want to deal with. So for recurring workloads, as I said, if they are weekly or monthly, you may want to choose a transient or serverless option rather than going for a long-running cluster. Going further in analysis, we also provide a data temperature analysis based on the frequency of access of data on HDFS. We also provide with a Hive table analysis with a detailed view of databases, and also once you delve in further inside, you are shown the detailed view of tables along with the last access time of the tables, and there is no information present if the table was not accessed at all. So this helps us identify the candidates which need to be moved out of the modernization or migration. Next, I want to showcase the migration inventory quickly. Sorry about that. There's a choice of region that is given, and once you choose that, you can quickly proceed to the migration inventory. Migration inventory is one of the richest features, which categorizes all the workloads into different categories of rehost, refactor, rebuild, and also an engine-wise classification, and also a classification based on the complexity of that workload. So rehost is a workload which can move to the target technology or the target service or to the cloud without a lot of change as is. A lift and shift case, basically. Refactor is the one which may require minimal changes, maybe in terms of configuration, or maybe very few changes here and there to make it compatible with the target technology or the cloud service. Rebuild are the cases wherein we are talking of moving something like a MapReduce code to a Spark code, which is the case wherein everything needs to be re-architected or rewritten. So those are the cases for rebuild. So this classification of workload is done into these categories to help customers plan their migration strategy and build their migration strategy. And the complexity classification that is given here can be taken into account in understanding the underlying complexity of the source system, the complexity that is involved in modernization, and then to further plan, because the complexity of the workload will also drive several other stages, including data validation, wherein if it goes all well, if it is all dealt with automatically, then it is all well. But for a more complex workload, even if there is the slightest error, then to reach to the root cause of the error and to understand if it requires rewriting becomes a longer process. So that is where a complexity really becomes very interesting. Now, in terms of the detailed report here, you can see the entire information coming here. I again want to highlight the reporting section, which kinds of presents all this information in the form of an Excel sheet, which can be downloaded. Now, for EMR in particular, we also present a rough estimate of the capacity based on the utilization patterns that the engine has seen so far. So based on the utilization patterns that the engine has seen, there are instances that are recommended, and based on the instance recommendation, we are also presenting a rough estimate of the infrastructure cost. Now, here we are presenting the pricing for EMR on EC2 with an on-demand pricing, and also a pricing if you choose 3-year reserve pricing. Going next, we have the transformation section. In the transformation section, you can choose what you want to transform from a query workload to latent to ETL. There's a lot of information that comes whenever you upload any code for transformation. For example, it highlights the total number of files if you're going for a SQL transformation, does a complete file analysis in terms of the complexities, the DDLs, the DMLs, and the number of entities involved, the recommendations around the same, the type of queries that were present, a complexity distribution of the queries if you want to go into that. And for Hive, there are various other terminologies involved. For example, there's the concept of the permanent table, there's concept of a temporary table or an intermediate table. So all that is presented here. Now, if I go deeper into this view, you have the file analysis, you have entities analysis. In file analysis also, you can go delve deeper, wherein in each file, you can look at the type of queries present in that file only, and the complexity that is getting accommodated in that particular modernization for that particular file. Then you have the entities analysis, query analysis, recommendations, and once you do the transformation, select the target technology and the transformation, then all this code that was uploaded here gets transformed and is available for download. For Spark code, for target as Spark, we also support packaging. There is another interesting area present here, which is around code assessment. So we do the code assessment for both SQL as well as non-SQL. In non-SQL world, MapReduce and Spark would come in. You just create an assessment, choose the engine, which can be MapReduce or Spark, give a name to your assessment, and there you go. You will be presented the stats of that code assessment, wherein you will be showcased the different attributes, not only the complexity, but also the different distributions. For example, the distribution of a MapReduce code based on the class type. The different jobs, in case of MapReduce, the jobs are usually run through a driver. So this section presents the various drivers, the information that is coming with them. So what kind of mappers are associated with that job, which is the reducer that is associated with that job, what is the input and output format, what is the map output key, etc. So I kind of rushed through the demo a little, but I would be more than happy to do a detailed demo if anyone of us here needs it anytime in near future. So I would like to rest it here unless there are any more questions. As I said, just one more thing to add, data validation is automated too, but it is done through a separate toolkit and is not part of this application, and hence we can take that up later.
Okay, terrific. Thank you very much for that great demonstration, Samiksha. We have run out of time, but I do want to ask just one question of each of you, both you, Samiksha, and Veena. Veena, maybe I'll start with you, if you don't mind. How do I choose between EMR on EC2 and EMR serverless for my application?
Thank you, and great demo, Samiksha. So this is a great question, and one that gets often asked by our customers and partners who are actually interested in trying out EMR serverless. And EMR actually offers 4 different deployment options, but for the sake of this discussion, let's focus on EMR on EC2 and EMR serverless. And as some of these architectures are not for all use cases, there are a few considerations that will help you determine which deployment option would be right for you. Customers can choose EMR and EC2 when they want to have maximum customization control over the EMR cluster. This is specifically the route many of our customers take when they move to AWS from an on-premise Hadoop deployment, which means that they have the Hadoop expertise to manage instance types and cluster sizes and so on. And obviously, this requires Hadoop operations and systems expertise to a degree. You don't need as much heavy lifting as you do on your on-premises, because we do automate several aspects like scaling or decoupling storage from compute and so on. But you do need to have some knowledge on capacity planning and infrastructure planning, which Leap Logic helps with as well. But if you want to start using EMR without all this overhead of having to manage and maintain clusters as an end user, you can go for EMR serverless when you just want to purely focus on the jobs to run rather than maintaining and managing the underlying infrastructure or environment. And one more thing is the utilization. We often find that if you're using your on-premise cluster more than 80% utilization, average utilization, we find that EMR and EC2 might be more cost-effective for you because we offer spot instances, Graviton support, and so on. But if you're not using your cluster to the fullest, if you're only using less than 50%, then you might find EMR serverless is more cost efficient, since we scale up and down dynamically and you only pay for what you use. And EMR is also fault tolerant to AC failures, availability zone failures. So if one availability zone is impaired, it automatically reroutes to a different AC. So these are some of the differences between EMR on EC2 and EMR serverless. And that's where I want to end, since because of the lack of time, but there are quite a few things to talk about. And I think we'll share the documentation links as well over the email, right? So you can read more.
Okay, terrific. Thank you so much. And the final question, Samiksha, how would you recommend that we start our migration project for EMR? And then that'll probably bring us to the end of our time today.
Sorry, I kind of, can you repeat the question for me?
Of course, yeah. How would you recommend that I get started with my migration project for EMR?
Okay, great. That is a great question. So, as we said, building the right foundation is most necessary for the success of any modernization or migration activity. So, if you want to migrate to EMR, one of the first things to do is to do the right assessment of the source platform, whether it be a non-SQL world, whether it be a Hadoop world from where you want to go to the EMR, or whether it be a SQL world, something like Teradata, from where you want to move to the EMR. Doing analysis and assessment first should be the first step. And there is enough talking we've done already around the need of doing this in an automated fashion. So LeapLogic can help in doing that in an automated fashion to take care of the assessment and discovery of the source platforms.
Fantastic. Unfortunately, we have run out of time at this point, so this will take us to the end here. I would like to thank all of our speakers. Thank you, Jim with TDWI, Veena with AWS, and Samiksha with Impetus. I would also like to thank Impetus for sponsoring today's webinar. And please remember that we did record today's webinar, and we'll be emailing you a link to an archived version of the presentation, which you can feel free to share with colleagues. Also, don't forget that if you'd like a copy of today's presentation, use the click here for a PDF line. Finally, I'd like to remind you that TDWI offers a wealth of information, including the latest research, reports, and webinars about BI, data warehousing, and a host of related topics. So please tap into that expertise at tdwi.org. And lastly, from all of us here, let me say thank you so much for attending. This does conclude today's event.